These are the notes for Unit 2, Day 5, and they start on page 14 of your packet. And so the title for this session is Derivative Rules. And so we've come away from our investigation in the previous class with one really powerful derivative rule. Sorry, another silly pun, but it is super powerful. So the essential question then is, how do we apply the power rule for more complicated functions? We did some really basic functions, and now we're going to really dive deep here and use that power rule as much as possible. Okay, so I've started every note session for the last couple of days with this. We're going to keep going with it. When I say derivative, you think, you can say it to yourself, right? Slope. When I say slope, you think derivative, right? So we're talking about the slope of a tangent line. That is our derivative. We got to more complicated functions, complicated polynomials, where that slope of that tangent line is different depending upon the location. So that's where we started seeing that pattern in the power and what happens. So we observe a pattern. Our shortcuts gets us what? So when the function is, the derivative is. Okay, so when we observe this pattern in the function, our power rule or our shortcut gets us this derivative. So here's our pattern in the function, right? We have a polynomial, it's a power of 2. We know that the derivative is 2x, right? Bring down the 2 and then reduce this power by 1. So it's 2x to the 1 power. That's the derivative. 2x to the 1 power is just 2x. So what is the derivative here? Go ahead and write it down. Okay, if you wrote down 3x squared, you're right. How about this derivative? Go ahead and write that down in your notes. 4x cubed. Oh, that's right. This is not in the notes. So you're just kind of thinking out loud here. My mistake. Sorry. Derivative x to the fifth of x to the fifth is 5x to the 4th, right? And we can just keep going, making the power bigger and bigger. Derivative of x to the 6th power. The derivative is bring down the 6x to the 5th, right? Reduce that power by 1, and so on. So every polynomial behaves this way. In fact, any time we can write an expression as a power, they behave this way. That's the really powerful thing about the power rule. So we're really going to use this. We're going to use this, and we're going to make sure that we focus on rewriting anything we see as x to a power. Okay, so what you're going to do is you are going to turn to page 113 in your text. And you are going to, this is bothering me, so I'm going to correct this because I've kind of redesigned this. There we go. Okay, you're going to turn to page 113 in your text and complete these two definitions. And then you are going to apply these two definitions to these two problems. So I'm going to go ahead and pause the video and turn to page 113 in your text and go ahead and write these things down. Okay, so I'm assuming you've written these things down, and you know from watching my videos that I'm really stressing taking the time to get into that textbook and to see what the textbook has to say. I think it's super important. It's a skill that, it's a kinesthetic skill that helps you remember things better. So again, if you haven't, go ahead and pause the video and get those things out of your text. Okay, so now we're for real here, right? You've got it into your notes from your textbook, and now you're comparing with what I have written here. So the constant multiple rule says this: if u is a differentiable function of x and c is a constant, so c is a constant, u is a differential function. So like 7x to the 5th power. That would be c times u, 7x to the 5th power, right? We differentiated x to the 5th. Now we're going to differentiate 7x to the 5th. If we have that scenario, then we can rewrite the derivative, bringing the constant out front, and then just doing the derivative of whatever that u polynomial was. So let's try that. Why don't you go ahead and try that with the function y equals 7x to the 5th. Okay, so go ahead and find the derivative, and then substitute in 1 so we can find the value of the slope. Okay, so differentiating 7x to the 5th, d dx, right? That's one of the notations. D dx of 7x to the 5th is 7, there's the c, the constant, times, now what is the derivative of x to the 5th? Bring down the power, reduce the power by 1, that's 5x to the 4th. Okay, so the derivative of 7x to the 5th with respect to x is 35x to the 4th. That's why we call this the constant multiple. We're taking the constant and we're multiplying it through. Okay, and you will get good at this very fast. You will just see this as 35x to the 4th. Okay, now we want to evaluate the derivative. This derivative holds for this whole function everywhere, but I want to know exactly what its value is at 1. So I'm going to go ahead and evaluate this. Look at this notation here. I'm evaluating the derivative of 7x to the 5th with respect to x at x equals 1. In other words, I'm taking the derivative, the 35x to the 4th, I'm putting 1 in there, and I'm finding this out numerically. So 1 to the 4th is 1 times 35 is 35. So if I would draw a tangent line at x equals 1, tangent to this curve, its slope would be 35. Super steep. Does that make sense? Let me say that again. If I were to go to x equals 1 on this function, and I were to draw a tangent line to this function, its slope would be 35, okay? Oh, let's talk about the sum and the difference rule. Sum and the difference rule means I can have multi-term expression and find the derivative of the whole thing just by finding the derivative of the pieces. You've actually already done this in our investigation, okay? So this is what it's saying. I can have like a binomial, like x squared plus 3x. And I can find the derivative by taking the derivative of x squared and by taking the derivative of 3x and by preserving that plus sign in between them, okay? So that being the case, if I want you to find the derivative of this expression, this might be a little tougher. So let me give you a hint. We need to FOIL this before we can do this, because we don't really have sums and differences right here. We have brackets raised to a power of 2, and we don't have that expression here. So go ahead and FOIL this, and then go ahead and take the derivative of each piece. So I pause the video and try to do that. Okay, if you're tuning back into the video, we're going to go through those steps now. So here's my function. I'm going to FOIL it, right? That means 2x minus 5 times 2x minus 5. So that's 4x squared minus 20x plus 25. And now I'm going to differentiate this. Notice I'm using different notation, and that's okay. We've got lots of notations to use. So I'm going to find f prime. So the derivative of 4x squared, bring down the 2, that's 8x. The derivative of 20x is just 20, because we're going to bring down the 1, and we're going to make this a power of 0. X to the 0 power means I don't write the variable x. And 25 is a constant, so the derivative of that is 0. So our derivative is 8x minus 20. And now I want to evaluate that derivative at 2. Okay, so I plug in 2. So the derivative at 2 is 8 times 2 minus 20. So 8 times 2 is 16, minus 20 is negative 4. So when x is equal to 2, this is a parabola, right? 4x squared, that's a parabola. So this parabola, when x equals 2, has a slope of negative 4. Okay. All right, let's take a look at some that are just slightly more complicated. So we are using the power rule, which means we have to make sure every term is written in terms of a power. So we have to remember how we write a power when we see a radical. Okay, we have to remember what fractional powers are, right? Here's another radical. So let's try these. Okay, so example 1, we have 3/5 times the square root of x minus 7x to the 4th. Now, if I just asked you 7x to the 4th, you could probably give me the derivative. Okay, but we're going to really grapple with this term here. So the 3/5 is the constant, right? That's just going to go out front and get multiplied through. Square root of x, okay? The square root of x is x to the half power. Remember that? When we have roots, we have fractional powers. And square root means I've got like a 2 here, like this is the 4th root down here in example 3. Okay, so I've rewritten it as a power. I'm rewriting each term as c times x to a power. C, 3/5 times x to a power. Okay, and then I have minus 7x to the 4th. That was already written as cx to a power. So I didn't have to change that at all. I didn't have to rewrite it. Okay, now I can do the power rule. I'm going to bring the half down and multiply it. And I'm going to subtract a half. Now let's think about this. If I subtract, excuse me, I'm subtracting 1. So if I'm at a half and I subtract 1, I have a new power of negative a half, right? It gets smaller. Okay, we're going to worry about that in just a little bit here. Let's do the derivative of the next term. Minus, bring down the 4, 7 times 4, x cubed, right? You probably already knew this was 28. All right, so let's simplify this. Well, first of all, let's multiply this fraction. We've got 3 over 10. So this derivative is 3 over 10, and x to the negative half, the negative means it should go in the denominator, and the half means I get my square root radical back. So I have 3 over 10 root x. That's going to be the common way of seeing that answer for that term. And then I got to simplify this. I'm going to write that as minus 28x cubed. So here's the derivative. I'm not asking you to evaluate it. Notice I'm just asking you for f prime of x. I'm just asking you to do the power rule and then go on to the next question. Okay, let's take a look at example 2. This is tricky because of this. Okay, what people don't realize is this is still cx to a power. Okay, and so we're going to rewrite it as such. C is the constant, and that's 1/6, right? We have a coefficient of 1 on the top here. So we bring that constant out front, 1/6 x squared minus e to the pi. Okay, now we can differentiate. Now everything's written as x to a power. Okay, and we can use the power rule. So let's bring down the 2. Let's reduce that power, x to the 1. We don't need the 1, but I'm going to put it in there. Now let's go to the next term. E to the pi. There's no x here, right? It's not e to the x, it's e to the pi. It's not x to the pi, it's e to the pi. E to the pi means, what is e? Remember, e is a number, about 2.7. Pi is a number. So this is 2.7 to the 3.14. This is a constant. We can calculate that on our calculator. What's the derivative of a constant? Derivative of a constant is 0. I'm going to pause the video here. I want you to look at this. Do you see my huge mistake in my notation? Right there. Holy cow. I got to stop the PowerPoint and I got to correct that. We should have, because we're doing the power rule, aren't we? We should have a power, we should have a prime there. Let me catch back up here. Click, click, click. I should have y prime there, okay? Because we were doing the power rule, weren't we? Right? We were bringing down the power, reducing the power. This is a constant 0. This is the derivative, and I forgot my derivative notation there. That's super important, and it still happens to me to this day. Sometimes I forget it. So I always like to go back and kind of look at things, make sure I've expressed them properly. Okay, let's simplify this. 1/6 times 2. Well, that's 2 over 6, or that's 1/3. So we're going to write that as 1/3 x, and then minus 0, I guess, but we don't really have to write minus 0. All right, let's take a look at example 3. So here's, the big kahuna here, right? I've got a whole bunch of stuff going on. So this function is 5x to the 2/3 power plus 9. Now remember, I got to write this as x to a power. X to the 1/4 power. Remember, it's a root. Roots, kind of like roots going in the ground. The 4 goes in the denominator, goes underneath. Okay, let's do our power rule. I got my prime here, right? F prime of x. I've got this adequately notated, not like the mistake I made over here. Let's start bringing down those powers. 5 times 2/3 x to the subtract 1. So this is what I think about when I'm working with fractions. I don't think 2/3 minus 1. I think 2/3 minus 3/3. That helps me. Okay, that helps me because that helps me subtract and get that new numerator. So 2/3 minus 3/3 is negative 1/3. All right, let's try this with the next term. So I got 9 times 1/4 x to the 1/4 minus 4/4. So can you kind of picture that in your mind? 1/4 minus 4/4 So -3/4. So that helps a lot. At least it helps me find that new power when I'm subtracting and using fractions. All right, so we've got this all situated. We just need to, looks like, do our fraction work here, right? This is 10/3 x to the cubed root in the bottom because I have -1/3. Plus 9/4, look at this messy thing down here, but that's how you're gonna see it, right? This is gonna be, it's a negative power, so it's gonna go downstairs. It's x cubed, right? But then it's a 4th root, so I'm gonna put it back in the root spot and put my radical back. So that's how you're gonna see that written. So to switch back and forth from fraction to radical is super, super important. Okay, so if you've got questions about how to go about doing that, hopefully the next couple of days we'll kind of shore up those skills, but please talk to me. We'll get you through it, okay? We'll get you comfortable with it. Okay, so we also can do a sum and difference rule symbolically. So this is not that bad, but it's a little goofy looking to begin with. So let's take a look at this. So I have h of x here, and h of x is -4f of x plus 3g of x plus 2. And I want to do the derivative. So don't think too much about this. This is like -4x squared, right? I would do -4 and then I do the power rule on x squared. Well, I don't have the function. So I literally just write this as -4 times f prime of x. What is the derivative of f of x? It's f prime of x, right? We're just working off the notation here. So let's try that with g of x. What's the derivative of 3g of x? It's 3g prime of x. That's the notation. What's the derivative of 0? Oh, spoiler alert. What's the derivative of 2? 0. Okay, so this is called symbolic representation. Okay, we don't know what f of x is. We don't know what g of x is. We just know that if we have the function, its derivative is f prime. If we have this function g, its derivative is g prime. That's all we really care about because we're going to get all the values up here. Okay, so we want h prime of 1. So we go to the table. When x is equal to 1, f prime is equal to 0, and g prime is equal to 4. We're going to put those here. Okay, f prime is equal f of 1. Okay, we're going to go and get f of 1 here, and we're going to go and get g of 1 here. Okay, and we're going to leave the 0 off here. Okay, now this intermediate step, you probably really quickly move beyond this step. We're going to grab that 0 and that 4 that I talked about a second ago, and you probably will jump to this step pretty quickly. You'll just say -4 times 0 and plus 3 times 4. Okay, so mathematically that is 12. So the derivative of h prime of 1 is 12. So let's try this one. Using the table, evaluate the derivative of g of x at x equals -1, right? Notice they always give you that value in the table. Sometimes they may give you extra rows too, just to confuse you. That's always fun. All right, let's differentiate this. So pause the video, try to do this differentiation symbolically like we did this over here. Okay, if you're tuning back in, then we're going to go through that symbolic differentiation right now. Give me just a second though, because you are not with your pod mates right now. This is because I redesigned the course. So there we go. Like to correct that stuff though as I go along. So you're going to see me making some mistakes. Okay, g prime of 1. So g prime of 1 is, oh, I just gave you the answer. I did just give you the answer. It's 33. Okay, so if you didn't get 33, what you need to say to me in the next class is, hey, Miss Potter, I didn't get the right answer for the notes. Can you go over that example for me? And I will. Okay, it just takes one person to ask. So that's your homework, is to ask that question if you didn't get 33. Okay, when we see each other in class, we'll go over the takeaways and we'll get started on those topic questions for the power rule.